Hello, everyone. Welcome to our presentation. We'll be presenting you how we migrated our recommendations domain from Relational DB to Couchbase. Maybe some of you will remember that last year we presented how we migrated our favorites domain from Graph DB to Couchbase. We use Couchbase a lot and love it a lot, actually. Let's introduce ourselves. I'm Fatih. I've been working for 2 years in Trendyol as a software engineer. Previously, I was working for a fintech company named EasyCo for 1 year. Emre, can you introduce yourself?
Yes, I'm Emre. I started to work in Trendyol when I was a student. Now I have been working in Trendyol as a software engineer for around 1.5 years.
Okay, let's go with Trendyol. And what is Trendyol and what Trendyol is doing? Basically, Trendyol is the largest e-commerce company in Turkey, and it grows day by day. It grows really fast. As our culture, all our processes and products are driven by technology. We even have a saying, technology is the driver, e-commerce is the outcome. Then in Trendyol, we both are in the recommendation team, recommendation and personalization team, actually. Our team is responsible for serving all products and basket recommendations. Also user interactions like favorites and collections. As I mentioned, last year we migrated our favorites domain from GraphDB to Couchbase. Let's continue. Here is our outline. For starters, we have a recommendation API, and it's getting thousands of requests per second. It's basically product recommendations, product-to-product recommendations. Initially, it was scaling our loads with relational DB structure, but since time passed, platform got bigger, and our initial design started to have some trouble handling that load, especially on events such as Black Friday. Then we have stopped using relational database and transformed our data source to NoSQL Couchbase without losing essential features. That was our important part. We shouldn't lose our essential part because our customers was like lots of them. So we wanted to share our experiences and tell you why and how we did it. Firstly, we will show you legacy design with relational DB, then our abandoning process of relational DB. Then we will tell you why we choose Couchbase. There are lots of NoSQL solutions. Why we choose Couchbase. Then we will be telling you new design with Couchbase. As you can imagine, migrating from relational DB to NoSQL DB makes lots of change, and we will be telling you our new design with Couchbase. Then observations after deployments, some good graphs will be presented. Let's talk about our legacy design with relational DB. Previously, we were running our recommendation business with two main tables. Actually, those are visibility and product recommendation tables. This little guy here means that we are versioning our tables. Some tests are made in Trendyol, and which algorithm, some algorithm wins, some does not. So we are serving these by A/B tables. Let's talk about visibility table. Visibility table holds the if product is visible on storefront or not. As you can imagine, in a day, new products arrive, and some products are becomes out of stock and other things, we have to know if one recommended product is visible on storefront or not, and we are and this table mainly works for this. The whole recommendation infrastructure was on Relational DB, but it had a cache on it with Couchbase for 30 minutes. Actually, we didn't have cache here at first, but recommendation domain grew larger by time. And as product count increased in Trendyol, our write frequency increased day by day. And our read performance was affected dramatically because of that, actually. And it had come to a point that we couldn't even drain the lag from the queue, where we listened to write messages. To not affect daily users, we were scaling our write consumers at nighttime, actually. Let's talk about schema. This represents our Relational DB, and this was our product invalidations, as I mentioned. This was causing lots of load, actually. And this team presented here is our data science team, and they are actually running some algorithms and recommending some products to others. And this queue represents that. Our project was written in Java and with the framework of Spring. As I told you, we were using Couchbase as cache after some time. And let's see how our lag affects us. We were actively using Kafka lag checker. It represents how much messages is staying in the queue without processing. And the screenshots show that we were really struggling to drain our queue. You can see that 62 million of messages were waiting in the queue. And this was not acceptable. And when we started to see these pictures, we decided to migrate our infrastructure, actually. The main reason of the lag was actually previously we were the messages was coming product to product recommendation, and for example, if 100 products recommending to one product, there will be 100 messages in our queue. There had to be, but with the new design, we are just storing all recommended products to a single document, actually. So it was not necessary to send those records one by one. And when we migrate our data structure, we didn't see any lags, actually. To imagine more clearly, this screenshot shows how our recommended products be seen on storefront. Let's talk about our abandoning process of Relational DB. As I told, the Relational DB couldn't handle our write throughput, and it was 140 or 150 millions per minute. It was actually affecting our read throughput either, and approximately it was 60 to 70 milliseconds, and it was much higher than our average. And the other thing was Trendyol is running on multi-DC So we are replicating. We had to replicate our data to our clusters, to our data centers. But with the relational DB, those solutions were not very good for us, and high writes caused lag in between DC replications. This graph shows our lag before the migration and after the migration. It's lessened so much. From now on, Emre will tell you why we choose Couchbase.
Thanks, Fatih. You were great. I want to tell you about why we chose Couchbase. It's because that our prior positive experiences in Trendyol, and it was very good before that. We transformed the favorites domain first, like Fatih said, and after that the collections. And for the recommendations domain, we first tried to change the grocery recommendations. Actually, it was gonna be made for the first time, and we tried the NoSQL solution in there, and we had a thing called that completion logic that we named it, and we were very successful at it. I will tell you about it in more detail. And based on that, the know-how of team members were very high. And it's low response time with key and value access. It's just when we needed to fetch the whole document, it was very quick to respond. And with the subdocument API, sometimes we didn't even need to take all the document, and we could just take the part of it and save the network from there. And it could handle high write throughput. And its multi-DC replication abilities were very good. In Trendyol, we increased our geographical redundancy very lately, and it means that every day we can deploy our apps to yet another cluster, which means we need to replicate the data very quickly, like Fatih said. And with these multi-DC replication abilities, which is called XDCR, we think that, according to our observations, Couchbase has the easiest and the most reliable replication solution with its fastness and its low network usage. And its horizontal scalability also, like new nodes can be added on the fly without affecting the system very easily. And its rich documentation and community support. We saw that lots of users use Couchbase worldwide, and with the official support, we were very easily, we could just take the answers and get help whenever we needed. I want to continue with the new design. In our new design, as you can see, the API and the consumer almost stays the same. It's just the difference that we wrote it with Go, since we now feel more comfortable with it and we are using it actively. And the several services still send product invalidations, and the team still sends our recommendations. But the major difference is that we now use Couchbase, and the main difference that we now have a document which has top products and all products. And with this design, before we were using Couchbase as cache, and now Couchbase is our only data source. And you can see that we are using culture in our key also, since we are working international. I want to first tell about why we chose Relational DB at first. It was because of the invalidation process. Like I said, it was easy to listen to invalidations and directly write it into the database, but it was getting harder to scale it since our domain grew larger by time. So now we tried a similar design, which just I said called completion, means that we wanted to achieve a similar behavior by holding a visibility bucket on the side, and this was listening to product invalidations, and it was also saving the data as for every product if it was visible or not, and this bucket helped us to know if that product is available to sale. And since a product generally has more sellers now, since the domain grew larger, we don't expect the product to have no seller as frequent as before. So what these top products and all products means is that in recommendations, we always aim to serve 24 recommendations for one product. So top products holds active 24 products to serve, which is sorted by score by default. The team sends it as sorted by score. And if as a fallback scenario, is since if I'm not getting invalidation from some reason, and if the product is deleted from the website or if it's stock out, and if one user sees less than 24 recommendations, I am sending the vanished content, vanished products or deleted product or stock out product to the consumer, and consumer replaces the deleted products with the products from all products. So when one user sees less than 24 recommendations, the users after it won't see that much of a vanished product, since it will be filled with the all products. And we remove when that happens, we remove that non-existent products, and from the highest score, we just replace it with the all products. And like Fatih said before, the rights were like delete product 1 from product 1, delete product 2 from product 1. So the Kafka queue had much lag, and also the network usage were very high between clusters from Kafka to us. And this resulted to many messages in queue and many more records waiting for process. And in the new design, since the recommendations are already in a list, we just take the up-to-date list from our queue, ask it to the visibility bucket, and replace the list in our data source by taking the most 24 active visible products to put it on top products, and the rest of them for fallback reasons, and replace the list in our data source. So the amount of messages we process from the queue decreased significantly from almost 150 million to around 20-30 million. Now I want to show you some code samples from our API. And as you can see that we are actively, like I said, using our subdocument API from Couchbase. And it just, in the API part, it just takes the top products, and if the document is not found, it means there is no recommendation for this product. So we are just returning an empty list. And if there's an error, we just log and throw the error, return the error actually. And if there is no problem, and no problem also by taking content in the lookup in result, we just return the 24 top products. After this, this code block ends, we are asking the detail API for the detail of this product. And if we realize that this product is not sellable for some reason, like I said, stock out or vanished or deleted or something like that, we send a record to our consumer to see that it's, to say it that, hey, this product is gone now, fill it with something else, so that the other users won't see 23 or 22 recommendations. They will just solidly see 24 recommendations. We just want to make sure that we are providing enough data for our users. After that, I want to talk about the recommendation process easily. It's just the data science team sends the records, and we just generate top products inside of them, and we just upsert the document to our database. The recommendation part is actually that easy. The completion part is a bit different, which is we believe we don't see that much often. And now in the completion part, it's just we take the document and we are seeing the vanished products, which is which came from the record in API, and we are removing those invisible products, and we are with this new generated active 24 top products, which maybe it can change in the future, so it's on enum. We are from all these top products, we are taking a slice of them and upsorting it again using subdocument API, and so we are making sure that by using this code block, we have top products, and from these top products we are filling the gaps and taking as we need it, and we are making sure it's 24 or something we want to give. And here are the observations after deployment. There will be lots of graphs actually. Actually, Fatih showed some of them, and I will show mostly the response times. And it's 58 milliseconds to 8 milliseconds. Before it was high, and we tried lots of things to lower it. We were scaling our consumers at night time, like Fatih said, or we were trying to minimize our records. We were trying to show less recommendations sometimes. Sometimes in events, we were trying to get it to a light mode to show users whatever we can, just to be able to show them something. But now we are able to show 24 products like almost all the time with 8 milliseconds response time. And this is the holy day that we switched the API. This graph you see is that it's an API that uses the recommendation API. It's our client API. And as you can see, the deployment time, and before it wasn't that stable, and it was so high, around 120 milliseconds. Now it's around 20 milliseconds, and it's all very stable. And now also our alert channel is very silent, I can say. And we are happy about this result. We felt so honored after we saw this graph. Thank you for listening to us.